Good evening, everyone. We are just about ready to get started on tonight's Advent of Code live stream in C++. We're going to be solving Day 13's puzzles, which unlock in just about 6 minutes from right now. Thank you to everyone who's joining the stream. Thank you also to all of you who are watching the replays on YouTube. As always, down in the description, you can find links to the Twitch live stream, the replays on YouTube, and my GitHub repository where I upload the code for all of these solutions. So last night, we finished up the puzzle for Day 12. It was, a relatively simple one. We kind of just had this little, language that described instructions for how to navigate our ferry, the boat that we're riding on, to our tropical island vacation. And, we had two different ways of interpreting that, but ultimately it was just about finding out where we end up after we apply all the instructions. So, this was a relatively simple puzzle last night. I have a feeling, I don't know, we're nearing about the halfway point of Advent of Code, and I think, typically, it's not a strictly linear ramp up of difficulty, and of course, everybody's experience, what they consider to be a difficult puzzle is different, but based on experience with past years, I think that we're going to start to see some more difficult puzzles in the days ahead. So sometimes, I might get tripped up a little bit. I might not have the solution right away. I might have to step away and come back and try something else. But we'll see how we do. We'll see how we do. I just ask you to bear with me as we do that. Of course, if you have any questions, any comments, you are always welcome to drop them in the chat of the Twitch live stream. If you're watching the replay on YouTube, feel free to leave a comment, and I will do my best to answer your questions. So we have just about 4 minutes to go until tonight's puzzle unlocks. One thing that I noticed here is that, we skipped some lines going down on the previous days, and now it looks like we're going back up on our little travel path. Now that we're on the boat, we've turned and we're going north. So yeah, this is kind of an interesting thing. It's not just a strictly linear pattern of all the days that we're going back and forth, north and south. I realize I'm saying the phrase strictly linear a lot tonight. I don't know. That just is on my brain. So now that we have about 3 minutes to go until the puzzle unlocks, we should go ahead and just set ourselves up by just making the directory in our code base for the puzzle. We will, as always, make a minimal little C++ program here just to start us off. We will write our build file so that the Bazel build system that I'm using knows how to build it. And then we will go ahead and just build and run that program. And we're all good to go. We have another couple of minutes before the puzzle unlocks, so maybe just to save us a little time, with almost all of these puzzles, we have needed both of our little utility libraries. Check, which is just, an assertion that works all the time, and the I/O library to do some file I/O, because we get our puzzle input as a file that we with these solutions, I've tended to just, pass the file name to read in as an argument. So we can go ahead and save ourselves a little time by putting those in ahead of time, because we will almost certainly need those in our solution program. Okay. Got that ready. Now if we run it this time, we should see a check failure. Yep. Yep, and there we go. All right. So now we are just counting down to tonight's puzzle unlock. Where will our ferry be taking us? On the way to our tropical vacation. Definitely miss travel and vacations. Nice to live vicariously through these puzzles. When the pandemic finally awaits, when we're all vaccinated, and stay with the social distancing and the masking after the vaccination, and I even have my vaccines t-shirts here, but once we finally get to the point where we've, stopped community transmission, I cannot wait to go on a nice vacation. That'll be really nice. All right. Day 13, puzzle unlocking. All right, ferry can make it safely to a nearby port, but it won't get much further. Darn it. Need to book another ship. Need to get from the port to the nearest airport. Each bus has an ID number that also indicates how often the bus leaves for the airport. Okay. Time set 0, every bus simultaneously departed. Okay. So the bus ID defines the intervals for how often it departs from the seaport. First line is your estimate of the earliest timestamp you could depart on a bus. Okay. Here, the earliest timestamp you could depart is 939, and the bus IDs in service are these. Okay. Earliest you could take. Okay. Was the ID of the earliest bus you can take to the airport multiplied by the number? Okay. So this seems relatively easy. I have a feeling that part 2 of the puzzle is going to get considerably more complicated. And I hope that it will actually load my input. Come on. There might be a little problem with the web. Oh, there we go, finally. Okay. Day 13. Now everything comes to life. So let's go ahead and take a look at what our input looks like. Okay, so it is really just 2 lines. All right. So do we have something in the I/O library? If not, it'll be fine. But yeah, we don't quite have an I/O routine that'll do exactly what we want, but we have some stuff that's pretty close. So let's first read in the file. Check that the number of lines is 2. And we'll say that first thing is we'll parse the earliest time, so we'll say check absil simple a to I to read the first line into that earliest time. And then we will say candidate, we'll have our candidate, we'll use a vector to represent our candidate buses. And then for each of these bus IDs in this comma delimited list, we will attempt to parse them as an integer, and if they don't parse, if they're just an x, we'll leave them alone. I have a feeling we're going to have to figure out something to do with these x's in part 2, though, but for now, we'll just include absil strings stir split.h, strings plural, there we go. And so we're going to split that second line, and we're going to split it by the comma character. And then if we can successfully parse that, then we will push it back on the list of candidate buses. Otherwise, we just let it go because it's going to be an X. I suppose just as a double check, we could make sure that it is, in fact, an X. Okay. Just as an early check, what do you say we print out some of this stuff, just make sure our parsing logic works okay with our input file? We'll go ahead and run our program on our test input for day 13. Okay. Oh, that should be else, because, yeah. That all looks correct. Okay. So, what we actually want to do with these is just find the first time after earliest time where one of these candidate buses evenly divides that time. So we could do a brute force search. We could divide and round up. You know, honestly, I think a brute force search is just going to be simple enough in this case. So what we'll do is we will say well, we already have our earliest time. We will increment minutes. Honestly, we'll just, each iteration of this loop, we're going to increment earliest time. Then we will say for each of the bus IDs in the candidate buses, if that time is divided evenly by the bus ID, which means that if, you know, the modulus, so we take the modulus, if there's no remainder, then we can leave at that time. So the actual answer that we want to spit out at that point is the waiting time. Okay, so we actually want to save the original earliest time. So we'll say equals earliest time, and we won't modify the earliest time because we want to know the difference here. But multiply the bus ID by the number of minutes you'd need to wait. Okay. Then we'll stop the program at that point. So I think we have our solution to part 1. We need to put in the dependency on the abseil strings library there. I mean, I think it got it transitively in the sandbox because the util libraries it includes, but, you know, still good to be explicit about that. Let's go ahead and, just as an example, use the test input that they gave us in the puzzle to see if our solution gives the correct answer for that. So we'll say, put that in test, run this for test. Okay, so it gives us, oh, okay, so that, we got something wrong because for the sample test that it gave us, the correct answer should be 295. Oh, you know what, it's going to be candidate time minus the earliest time, of course, because it's the number of minutes we need to wait. Let's try that again. Yep, 295. So let's try it on our actual test input. We get 2,095 minutes that we need to wait. That is a long time. Let's see if that's correct. Yep. Okay, let's continue to part 2. Shell companies are running a contest. 1 gold coin for anyone that can find the earliest timestamp such that the first bus ID departs at that time, and each subsequent listed ID departs at the subsequent minute. First line is no longer relevant. An X in the schedule means there are no constraints. Okay. Okay. Those bus ID... Okay. The only bus departures that matters are the listed bus IDs at their specific offsets from T's. They can depart at other times, and other bus IDs can depart at those times. Okay. Oh boy. All right, this is a tricky one. Tricky math that we have to do in this puzzle. So first thing I'm going to do is copy our part 1 solution. To part 2. Just use that to start. Now in part 2 here, so first line no longer matters. That earliest time, can get rid of that. And this thing that actually spits out the solution no longer matters. Now, the x's are important now to an extent. We have to find, there has to be some bus that satisfies those. But honestly, the bus that satisfies those could just be I don't think it really matters which bus satisfies those, because, like, for instance, well, so it's giving us this example where we have 7, 13, 59, 31, and 19. But all those x's represent are just gaps. Like, we could have bus number, like, if I'm looking over at the example here, like, this time we could literally have bus number, 1,068,783 just depart at this time, and it's fine. So really the x's are only relevant because they're gaps. So I think what we need to do is we need to figure out what the restrictions on each bus ID are, and then so we have to okay. So I'm just gonna have a struct here that represents constraints on a bus. So so within the constraints, we're going to have the ID of the bus, and we're going to have the offset of that ID. Now, because we're going to have to do math in a really huge domain with really big numbers, I'm just going to make everything an int64. Just so that, I don't get surprised by rounding or casting anywhere. So we'll just do everything int64. And include C standard int for that. Oh, yeah, already put it in. Great. So, so if we successfully, okay, so we'll say bus constraints are what we're parsing a vector of here. And although these are small enough to be parsed as int, I'm just deciding to do everything 64-bit. And so no matter if it's an x or not, we increase the offset at the end of this loop iteration because, yeah, that's what we need. So once we've parsed this, we get to the point where we have this vector of constraints, right? And we need to find a number that satisfies all of the constraints such that for each one, number plus offset is divisible by ID. So is this going to be something, with like a least common multiple algorithm, like a little tweak on that, I think. Are all these bus IDs prime, I wonder? Uh, that is an interesting one. So, 41 is prime, 37 is prime. I'm looking at a list now. 557 is prime, 29 is prime, 13 and 17 are prime, 23 is prime, 419 is prime, and 19 is prime. Okay. All of the bus IDs they gave us are prime numbers. Curious. So, I think that that has got to be part of the trick to this, because the least common multiples of primes are just the actual multiples of the primes, because they have no. I mean, this would even work even if these numbers were just relatively prime, but they are actually prime. So I think that that may be part of the trick to this puzzle. So if we were to just multiply all of them together, So if we multiplied all of these numbers together, though, they would all just start exactly at the number that we give them. So we need to take the offsets into account. Um, hmm. So I am going to open up another little text editor, and I'm just going to sketch a little bit of math while I try and figure this out with all of you live. So for a given, so for each of these offsets, we need to find x such that x minus offset modulo ID is 0. And so if we were trying to solve it just for one of these, we could... Just trying to remember all of my modular arithmetic here. But should be x I think that is correct. We just do that in the modular domain, but then we have to do this for other IDs and offsets. See, now you're starting to watch me flail a little bit as I'm trying to remember all my modular arithmetic. Let's see here. I think the fact, I still think that the fact that these numbers are prime is a big, it should be a big clue. So one thing that I want to try before doing too much clever math here is just, apply that, idea that the IDs are all prime numbers, and I feel like the solution is going to have to be something involving I feel like the solution has to be something involving the product of all those prime numbers. Or, But if we just go to the product of all those prime numbers, then the thing that we're going to find is going to be a time. Any multiple of the product of those prime numbers is going to be a time when all of the buses leave. So that's not exactly it. So I'm looking up some math, and it says, in general, the solution to x equals well, here, I'll put this on the screen, and we'll see what we can do with this. Okay, compute n as the product of all the moduluses. For each I in that range, we compute y sub I is equal to n divided by n sub I equals okay. This might give me enough to work from finally. All right. So Just a sec here. So we'll go through each of these. We're going to multiply together all of their IDs, which are the moduluses in these individual equations. The next thing that we are going to do is calculate these y values. So for each of the for each one for the bus, we'll push back. That's just going to be n divided by the particular modulus or ID for that given bus. And then we need to compute the inverses of these in the particular modular domain of each of the buses that's defined by its ID. So we'll write a little function to do Euclid's extended algorithm to get us that number. So we'll say so this is a little bit frustrating because I am at a point now where I feel like I've figured out how to express this in terms of a system of congruences in modular arithmetic, but I'm just applying the arithmetic in some wrong way and not getting the correct answer. So I may want to take a step back instead of just continuing to kind of like ponder while I'm on the live stream here, and I will get into a second session maybe where I actually figure out the solution to this, because I wouldn't necessarily say that I'm stuck, but I feel like I need to do a little more research and ponder this over so that I'm actually understanding the math that is going into this. And then once I have a little bit better of an idea, I will post another stream. So again, thank you to everyone for watching. You can always find the replays of these streams up on my YouTube channel. That's youtube.com/spoonboy42. Once I get the solutions, the code always goes up in my GitHub repo. You can find the particular repo at github.com/Craig-Chasseur/AOC2020. I will go ahead and put that on the screen right now. Thank you for watching. I am going to continue pondering this a little bit, and I will publish another video once I actually figure out what I'm doing and have a solution for you. So thank you. Okay, people, after a very brief delay, I actually have come up with a solution now for the day 13 part 2 problem. So a lot of what we were already looking at doing with using the Chinese remainder theorem was correct. It was just the last step I was getting something a little bit wrong. So the Chinese remainder theorem, just as a refresher here, I will try and bring up a page where we can show it here, but it gives us a way of solving a system of equations that are modular congruences. So this one at the website brilliant.org is kind of the example that I've been looking at. And this is basically the guide that I was going from for writing my code. So definitely give credit where credit is due. This wiki on brilliant.org had a nice, simple description of the theorem and how to apply it, and it's what I was basing my code on. So if we go back over to my code, you can see here that first thing I'm doing is I'm computing that product, that n, for the product of all of those, and then this result, I'm just adding up all of the terms that have, so we have the offset of a particular bus, which is its remainder, times the modular inverse of the product, in the modulus, which is the bus's ID, times the partial product, which is just everything in the product except for that particular bus's ID. As we already saw, all the bus IDs are prime, so of course they're all relatively prime to each other. We sum that all up, we take that modulus, that big product, and then the one thing that I was getting wrong is I was just spitting out this answer, but we actually want to take the product of all those bus IDs, which is also the least common multiple of all the bus IDs, because of course they are all prime and therefore all relatively prime. And then we want to subtract that result from that to get the beginning of the sequence that counts up to where we want to be. And honestly, I just found this by kind of messing around with the numbers and noticing that the wrong answers I was getting seemed to be about as off from the right answers as would sum up to make that overall product. So I kind of just looked at the numbers and said, aha, this is what's going wrong. So you can see the modular inverse here just uses the extended Euclid's algorithm to find the inverses here. And we actually got our correct answer tonight. I tried this out with my puzzle inputs and I got it okay. So what I would say for this is just that this was one where, for me at least, the math was kind of tricky. And I think the important thing was realizing that this uses modular arithmetic. This is a system of congruences in modular arithmetic, and kind of looking up how to solve that, finding the Chinese remainder theorem, and being able to apply that. I have a feeling that if I were back in college and in this semester I was just finishing up my discrete math course, I would have gotten here a lot faster. I'd be like, aha, I know exactly what I'm doing. But I'm a little rusty on that. I will totally admit, had to look up both the Chinese remainder theorem and the Euclid's extended algorithm to figure out how to do this. So I guess the moral of the story is trying to figure out, if you know that there's something mathematically tricky, try and figure out, you don't have to know the solution, but you have to kind of figure out how to express the problem mathematically. And then, when I realized it was kind of a system of not equations, but congruences, because we're working with modular arithmetic, then I'm like, okay, I know how to express this with modular arithmetic. Now I need to actually go and Google and see how to solve that system. And the answer was the Chinese remainder theorem. And honestly, I got stuck for a very long time just not applying this final step. That said, still was in the top 3,000 on the leaderboard after an hour and 40 minutes. Not the worst in the world by any stretch of the imagination. But we have definitely gotten to a point now where we have a puzzle that's kind of tricky. At least was tricky for me. This, I would say, of all the puzzles that we've attempted so far this year, was by far the most difficult for me. Hopefully I'll do a little bit better in the future, but sometimes I may falter. I think that puzzles involving linear algebra and modular arithmetic last year, I definitely struggled with those a little bit more and took a little more time on those solutions. But everybody's different. Like I am a little rusty on the math background for this stuff, but it's a good way to get more practice, and I think that is kind of the beauty of something like Advent of Code, especially as you get into the trickier puzzles, is it gives you a way to refresh on things that you haven't done in a while, gives you a way to learn new skills, both programming and math skills, figure out new things or relearn things that you haven't done in a while. So I still had a lot of fun with this. So again, thank you to everybody who watched the stream. Stream replay is always available on my YouTube channel, youtube.com/spoonboy42. Code will always go up in my GitHub repo at github.com/craig-chasseur/AOC2020. You can find the links for both down in the description. Thank you very much for watching tonight. Thank you for bearing with me as I struggled through some of this. I appreciate you being here with me and having some fun while we solve these puzzles, and I look forward to seeing you again tomorrow night. Thanks very much. Bye-bye.